This podcast is supported by Avner Ben-Bassat, your meeting place for the industrial community.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Sieber. Good morning, afternoon, evening to wherever you are, dear listener.
Good morning, Peter. What do you have in the news part?
I have two topics. One is physical AI.
Okay.
Some of you may have heard about already. And the other one is, I call it coding productivity. There's a couple of things we heard over the last weeks with regards to becoming more productive.
Let's talk about physics and AI.
Did you hear pop star Jensen Huang at CES? Most of us will have heard. Siemens was there. Also, Peter was there. I don't know if you saw that one. Computer electronics show in Las Vegas. Jensen was in a new shiny leather jacket I saw. Not his old jacket. I like the other one better, but there you go.
Yeah.
There you go. So he presented a roadmap, right? And there's a couple of stages. So there's what he calls perception AI. I think that is what we, in the first years of our recordings, 5-6 years ago, machine learning, that basis. And specifically, he talks about speech recognition. Now, on a side note here, there is this paper from the Aalborg University, and that is about XLSTM outperforming conformers, and that's the same in this case, I understand, as transformers, as well as Mamba on single channel speech enhancement. So that's, as I say, more on a side note of, this is one stage. And of course, the base technology continues to be improved. And this is an example there, I guess. So then Jensen goes on with the second phase of his roadmap, which is then, we're in the middle of that one, I guess, generative AI, content creation. Right, we've been talking about this one for the last 2 years, I guess. The third one, nothing, well, what should I say? Nothing new. Agentic. I love the word. Agents.
Oh, Peter, I have agentic news also.
Oh, really? Looking forward to.
Yep.
Can bring it now or later, whatever we want.
I can bring it now because I have a reading tip because there's a good white paper from Google. I will link to the paper and the summary. It's pretty good. It's a pretty good introduction to the whole topic. What is a model? What is an agent? How to combine both. It's very interesting, very good work by, I think, 3 Google guys.
Because you and I, we talked about it in our very first news update of the year. Then I did the interview with Armin Harzalic from Siemens last week. And actually, we did put a couple of links there as well. And one of the papers, which is the one that questions, is this AI or normal software? And I think you were trying to contact the guys, right?
I wrote an email to Professor Dr. Woolrich, and he's now a professor at University of Oxford, and I invited him to the podcast, but he didn't answer, so I will try again.
Well, yeah, maybe he's listening now. Or
maybe
you are one of his students. So we would be very interested in going back, what did we say? I believe it's 29 years that they were already asking these questions. So that was as far as Jensen is concerned, kind of the new agentic AI. So coding assistant, customer service, travel agent, we've talked about it, right? So these are all topics that we've talked about. And in addition, you have a separate robotics podcast. So now there you move into physical AI, right? And that's where what he says physical AI, again, is then actually robotics in most cases, but not necessarily always as, I wasn't going to talk about humanoids, but in this case it is because self-driving cars are part of it. So when we talk self-driving cars, we still see cars. We still see cars as we know them, very general, maybe with some changes there. Is not necessarily steering wheel. That's the major difference. But that's what he calls physical AI.
But what about the whole topic simulation and AI?
Yeah, we come to that. We come to that in a moment as well. Let me finish this thought here. He says it needs to be, or it sits on top of agentic. So it's just, again, I think it's a lot of different wording. Nevertheless, I don't want to question his his long-term view. I mean, we talked about embedded or embodied AI, right? Now, as far as he's concerned, and then we move into exactly your question here, this physical AI needs an understanding of the physical world. So it needs models to grasp our world, our three-dimensional world, concept, gravity, change, weather, whatever. And then he comes with this concept of three computers. I don't know if you heard it. Yeah, nothing really new there, but nevertheless, it's a nice way. I don't know if he came out with it or one of his colleagues. I'll share another thought on this one that I had similarly, like probably 25 years ago. And then you know what company it's about. But it's about the role that he wants to play in, let's say, nothing less than conquering the world, which he's doing a very good job at already today. So he has three computers. One is for training the AI models. Now the answer, number two, computer, is simulation, digital twins, whatever you call them. It's always about simulation modeling. And actually, I'm not that certain. Well, maybe I do understand the differences, but the number one is about models. Maybe number one, I think that is a difference. So if the number one computer is about what we've been talking about, training of AI models, the huge, fast, trillion data point kind of modeling and performance that you need. By the way, he does mention the very high demand on computing resources for transformers, just on a side note here. And then the second one, I guess, is when you then have these models ready, then you can go inside of the model and play. You have this factory that you're looking at that doesn't exist. It's going to be built next year, but already the people building the factory are now driving around their whatever automated vehicles, robots, humans, etc., etc. And is there a third one? Oh yeah, and the third one are then the deployment computers. I would call it inference, right?
Yep.
So wherever we put then a preferred NVIDIA inside, so to say, PC, whatever we call it, edge computer, in a car, in a robot, we've been calling it the edge, right? So maybe you hear what I say. I'm not sure that that is really new. I mean, he wants to say, NVIDIA, want to be inside any of those three.
Exactly.
I don't think that they are really new. I think the new thing maybe is the term physical AI. And when Jensen says it, that's something that people are probably going to pick up. Just very quickly, the thought I had back, because I look back at Hannover Messe's CeBIT, 600,000 visitors. That must have been 1993. So where am I with that's more than 30 years ago. And that was at that time the Intel designated CEO in line, Dave House, and I was in charge of and doing exactly the PowerPoint for us together with him, right? So I know exactly, I can very well imagine. And the point I was going to make is that at that time, Intel claiming both the consumer, and as far as I recall, it was very well including graphics and gaming, right? So not that they were not aware of that at that time, and the IT space. So here we go. What is your view on what he presented here?
I think he also presented this Cosmos, right? This new World Foundation models, right?
Yeah, that would then be the first one. Yeah, right, exactly.
Yeah, exactly. I think they wrote it's orientated by physics or physics orientated. So the whole model is physics orientated. So physics is a big thing, I think, for NVIDIA. And I'm very impressed. Every day the NVIDIA guys come up with something new. But how long can they keep this up, Peter?
That's a very good question. I mean, we did a simulation slot together with Johannes Brandstätter, who has his own very specific approach. Simulation is a big, well, to be honest, and who am I? This is Jensen and this is the Peter Seabrook. Was there something new? I think new was maybe the term, so to say, right? And I believe, and I was going to say, every single line of code, my second topic, as I said, is going to be later on about code productivity, is going to be directly or indirectly built on CUDA, right? And then slash I saw this as well. I heard this as well. This Cosmos, which is then the Cosmos is then the world model that we talked about, right? And that I can simulate in. So what is new there? What is going to be more? One thing I refer to is that he did say, which is good for him. Again, one link back to this company, Intel. I mean, the group that we were in, or related to hundreds of people only here in the Munich office, it was always about, are we sure that the market needs this power that we provide with, at that time, Pentium processor, or are we providing way too much? Now, it's almost like at the moment, it's like he's got this wonderful advantage of the market asking for more and more power all the time, right? Until a point where maybe of course, when we need more power, then he can provide a solution. But then maybe the world is going to say, oh, but we need to be careful. We need to be careful because at some point in time, cars, CO2, and then ships and planes. And as we all know, in the meantime, people say, oh no, AI is taking a specific share. Maybe at the moment it's only 1%. And even if it wasn't 1%, if it's going to grow to 5%, that's probably something that we do not want. So maybe there's a topic for the next future game. How long he can continue to do that? If I understood it correctly, it's not just about him, about his company providing the chip designs, the chips, but it's about partnering. There was one foil. So he's got this huge ecosystem of companies that want to be part of his approach.
Yeah, but do you think that they push with their models and their software solution only their hardware, or is there also a business model for NVIDIA when it comes to software and models?
Oh, there you go. Now you did or are still doing an open source separate podcast as well. He did announce. Did he announce what? I think the Cosmos. He announced
Cosmos,
open source, right? On GitHub. Yeah, there you go. So, and again, that is not to be said. The famous quote, open source doesn't mean free beer, right? It means that you can use, and there's typically always some kind of generation of dollars, so to say, in the end. So, but I'm not sure how he will generate it or the ecosystem around his company.
Mm-hmm. Okay. Peter, what else do you have? Or should I go on?
Yeah, please go. Yeah.
I have 2 reading tips today. My second reading tip it's from Nature by Frank Hutter. And our loyal listeners know Frank has already presented Tab PFN, I think 2 years ago. And now he's founded a company and sees Tab PFM as a foundation model for tabular data. And it should also be able to handle time series. And you will talk to him, and you did some research, and you wrote me a message, Robert, he can solve also time series problems with Tab PFN. That was very impressive, right?
Yeah, I didn't look into it yet. And I don't recall, because Frank and the team of PhD students, right, they were with us. When was that? A year or 2 ago at Arburg?
2.
When we did our conference with Arburg. And I don't recall if already at that time they were thinking it sounds a little bit like XLSTM, where they were looking at words. Is that at language? Sorry, that's the term, at language. Yeah. And then suddenly it seemed to be XLSTM also works on images.
Yeah.
And I'm not sure.
Yeah, he wrote that in his blog. He said, we were surprised that it also works for time series.
There you go. Yeah. Okay. Then when I was right with my assumption. So it seems to be the same, that they have been looking at tabular data for years, right? For a very, very long time. Congratulations again to the guys with having now appeared in Nature. And yes, then when Frank is going to be available in the next couple of weeks, I'm very much looking forward to hear from him.
You were skeptical, right?
No, but we have been hearing about time series now for the last 1 or 2 years, only every now and then. And it was always the relationship with the foundation models. And bottom line, it was so many times, don't forget our good is not the good old-fashioned AI, but it's more, we have so many different approaches from, I think, the good old ARIMA I think that's the standard one. And it was always a discussion about, well, why are we using foundation models? And then always, if you have a hammer, every problem you see is a nail and stuff like that. And that's okay. And we haven't talked. And then there was something and the guys didn't reply. And if there is now a solution, sure, we need to look at and then I always ask for, because then what typically happens is there's a couple of data sets. Oh yeah, and you're right. That's what I saw even also with the industrial. But what they were looking at as part of TAP PFM, they were tabular data. I think there was one Mercedes-Benz. It was about Mercedes-Benz on the test station and how can we reduce. It's a Kaggle competition actually. And another one was also industrial. But that's not what this is about. So you can apply TAP PFN to whatever kind of tabular data, including, of course, in our industrial world as well. But then the other one we're talking about now is, giving it time series data. So, and then we need to, and I'm sure, Frank knows what he's doing, that he's going to compare it to, okay, here's TAP PFN with a number of data sets in, as always, I assume, the financial work, the retail, logistics, wherever we have, and we have everywhere time series. And of course, and including industrial data, and then we need to see. Then we need to see how it's working, right? So I'm very much looking forward to learn from Frank, both for the tabular as well as the time series.
I have one spoiler for you, and I want to briefly stay with Frank and the AutoML community, because Frank is part of this AutoML community. I did an interview with Professor Dr. Marius Lindau from the University of Hannover about the future of AutoML, because we talked a lot about AutoML at the beginning of our podcast when it comes to domain knowledge and domain specific knowledge, and the guy at the machine can now run the machine and can use machine learning. But AutoML, it becomes quiet then, and I thought, let's do an episode about the future of AutoML. This episode will come out sometime in February. Very interesting with Marius Lindau. Kudos to Marius for your time. So a little spoiler for you and the whole community.
So is there a future? Okay, we're going to wait. Yeah, you're right. But that's again a thing that I will then ask Frank as well, of course. Let's see where we are. And I'm not sure. I need to get into my brain and ask it like a ChatGPT where that has been going. Has it triggered an industry? First thought I have, is there a relation then between AutoML and then big jump towards generative AI? Are the concepts completely different? Because as you remind me, AutoML is doing machine learning. So we are at the very first phase, which comes actually after the good old-fashioned AI or overlap, I don't know. And then it was saying about, instead of putting it in the hands of the data scientists, so to say, and I come back to this topic as a closure.
Maybe this was a misinterpretation by us or by the whole industry. But let's listen to Marius.
Yeah, sure. We will. Yeah. I'm just thinking myself about where that went. But I'll move on with this topic exactly now, because there were a couple of, let's say, topics, and they were all related to what I call coding productivity. So Andrew Ng talks about good times ahead for product managers of AI-based solutions. I would have never thought about that, but if Andrew is saying it with his fingers in so many different companies, knowing exactly. So quote unquote, he says,
this is like the Bible for you, right? His blog.
Oh, yeah. Well, he's one of the, maybe. Well, it's a bit strong.
It's your AI Bible.
Is there? The Bible has a New Testament and Old Testament, so maybe he's one of, no, I would say, sure, he's one of the 5 to 10 people that whatever he says, but I do not always agree with him. But that's maybe the same for the Bible, or, well... No, I want to be careful here. For religious people, for who the Bible is the Bible, I don't want to say that you...
Yeah, please go on with coding.
So, but he says, quote unquote, writing software, especially prototypes, is becoming cheaper. This will lead to increased demand for people who can decide what to build. AI product management has a bright future. So then he talks about this engineer to PM for product manager ratio of, he takes an example, 6:1. In your company, it can be it can be maybe 60:1, or maybe it's 2:1, whatever. I mean, he takes this as maybe it's an average of the companies where he's in. And yes, I can agree that as coding becomes more efficient And he doesn't specifically talk. He has a very interesting approach to not saying, are we going to need less coders? He will never mention that, right? The relation will change. More certainly. Is it going to be 4-1 or 2-1? And what does that mean? Now, before I come to my interpretation, I'm going to combine that with, there was another announcement from Salesforce. Now, you saw that one. So Salesforce says they're not going to be hiring any more software engineers in this year, 2025.
Oh, okay.
And that's related to the productivity boost by AI. Now, there's another guy we've all heard about, Mark Zuckerberg, and he says mid-level AI engineers might claim coding jobs from professionals at Meta in this year as well, 2025. Now, we have discussed this topic a couple of times, and I have received a number of shitstorms over the last years. Not sure again, but hey, guys and girls, come on, don't. I mean, do we see a productivity change or not? And some of you see it maybe 5%, others of you see it 40%, but there is something is happening there, right? And closing your eyes in front of seeing that there is a change, I would say is not the right thing to do. So I would say that, yes, I would agree that the relation between the PM, I would never have thought about this job, the product manager. But there you go.
Let me come back to the product manager, because we had a very nice episode on this topic with, maybe you remember, Anna Maria Brunhofer-Perdemonte from Impact AI, and they are building this platform for AI product manager.
Oh, there you go.
Yeah, and I remembered that you said, "Oh, I'm not interested in product manager. What kind of episode is this?" And now,
no, I would never say that.
and now we are back.
Oh, there you go. Maybe I need to go back. I did see her. I came across her name again, and maybe I was looking back actually for the Frank episode in.
Okay.
I did it on podcast on Spotify, I think.
Okay.
And that's how I see. So maybe I need to go back.
Yep.
Yeah, there you go. Why not? Perfectly okay. I would just not have thought about it, but there you go. And this relationship is going to change. Yes, I would agree. Now, I think that for each of you listeners, coders, or today if you are a product manager today, I guess you're doing fine. Just stay where you are or change whatever you want to do, but it seems you're on the right track. For you coders, I think you need to decide for yourself. Are you at the very core center and nobody's going to take away anything from you? Are you at the side? Are you new? And then I go one step further. That's what I've always been saying. I think it's a domain expert, right? And not today, maybe not even tomorrow, but in the next couple of weeks, months, years. One step further, the domain expert, I'm convinced, is going to decide what he or she wants to build. I am a domain expert. Maybe I studied or not, or I just moved into doing whatever, working at where I'm working, and I see that something is not okay here. And I have this user interface, and I'm going to tell the user interface, look at this. This is not okay. Can you please change it to be this or that? And this person, and then there's no product manager in between, I believe. Maybe there is still one for representing hundreds of domain experts, just to make sure that they have the tools, et cetera, et cetera. And this domain expert has zero interest in the code that is going to be generated on the fly by whatever is under the hood, Gen AI, agents, et cetera, et cetera. So from that perspective, I need to get back to and listen to the podcast on the product manager platform, I guess.
Exactly. Let's move to the main part.
Very good.
I talked to Avner Ben-Bassat about reinforcement learning. He's the president and CEO of Platane Technologies, an Israeli company based in Israel. Very interesting episode. Avner is a listener of our podcast, and he wrote in the email, "I want to be part of your podcast. Can we record an episode?" And here we are. Let's move to the main part and listen to Avner.
Very good. Looking forward to as well. At least 2 podcasts to listen to today, tomorrow.
Exactly. Thanks, Peter. Bye-bye.
Robert, thank you very much. Have a good day. Talk to you again soon. We see each other in 2-3 days. Actually,
Today we saw us on on when you listen to this
when you
episode, Peter.
listeners, yeah, right, we will have recorded already the Hannover Messe Industrial AI Conference in Frankfurt for Robert and me now in 2 days. And you will hear about it the next time that we talk.
Yeah, absolutely. Thanks a lot, Peter. Bye bye.
Thanks. Bye bye.
My guest today is Avner Ben-Bassat from Platane. Welcome, Avner.
Thanks, Robert. It's a pleasure to be here.
You are based in Israel, but before we talk about industrial AI, please introduce yourself briefly to the listeners, Avner.
Sure. Thanks, Robert. So I'm the CEO of our company, Platane. Platane specializes in AI-based applications for manufacturing. All our work is in the manufacturing space. We do work with some of the industry giants and also with the smallest of suppliers across many supply chains. And we're proud to partner with research organizations, universities, but also fellow software providers such as SAP and Microsoft. With a vision to bring AI to manufacturing, there's clearly a lot of opportunity and a lot of work to do. And it's a very exciting time, I think, for all of us.
Absolutely. Avner, quoting from your website, Platane's AI-based digital assistants provide production managers and employees with actionable predictions and recommendations that enable them to optimize production processes and solve manufacturing problems in real time. That sounds like an LLM with more or less clever agents for an ERP system, or am I wrong?
Let me perhaps explain more and clarify that, because, LLM being a language model is one application of AI, but LLM lacks, I think, ability to solve problems, and it certainly doesn't have the domain expertise of manufacturing.
But you can train it.
Exactly, but also it doesn't know the language of a manufacturing plant. But I'll get back to that in a second. When we look at manufacturing operations today, first we see very complex environment. Physically complex, large, noisy, messy. Even the smallest operations will have dozens of employees, let alone hundreds or thousands. And, with one objective goal to make product on time, on quality, etc. What we also see is that decisions are made by many people. It's not only the factory CEO, he or she makes decisions every day. It's many, if not all of the production employees. The operator of a given station often needs to decide which job to do first and which one to do later, which material to use now and which one to save for later, when to stop for maintenance. The warehouse manager will get instructions to get, 4 units of material, but there could be 50 of them in storage. So which one should he take? And so on and so forth. And the same for the planner and quality manager, etc. Now, in today's IT environment, we see many disconnected systems, a lot of legacy environments.
Warehouse management system, ERP, yeah.
Exactly, ERP, MES, et cetera. And unfortunately, a lot of Excel and paperwork to fill in a lot of white spaces. So at the end of this, you have numerous employees making a lot of decisions, lacking a lot of data. And today, also with the younger employees coming into the workforce, also lacking the experience that, the veteran meisters used to have. So now we have a lot of people making decisions, not always coordinated, not always the best one, certainly not on time. So our vision is to bring AI in applications in their hands to help them do a better job. So for example, if we are making recommendations about the schedule of production, how can AI make it better? So that every employee gets a very specific recommendation of what to do when. Robert, you are operating in station number 1. Do job number 1 first and job number 2 second. I need to bring you material. So I'm getting recommendations which materials to pull for Robert and which ones to bring for Helen at 2 o'clock or 4 o'clock. And all of us using digital assistance applications are continuously given recommendations of what is the best decision to make at any given point.
But this is not AI rocket science, right?
Well, because you're trying to solve a very complex problem. And the problem, if you think about it, is multidimensional. You're talking about hundreds or thousands or tens of thousands of jobs onto hundreds of stations with thousands of materials and dozens of employees. And we refer to it as the W6 challenge. Who does what, where, when, with what, and so on and so forth. And it's very hard to solve. And then people spend days to create a plan for the next week. And then with the smallest disruption, the whole plan falls apart. One employee, unfortunately, falls ill. A supplier is late in supplying parts. A machine breaks down. And then in real time, how do you replan and then coordinate everything again? And this is where we see organizations being challenged. And the AI comes into play by, first of all, understanding the production environment, collecting the data into context, contextualizing the manufacturing environment, understanding what's happening, predicting what's going to happen. By the way, if something bad is going to happen, we want to raise the alert. Hey, supervisor, your job is going to be late. Or, hey, quality manager, you're going to have a quality issue with part number 1, 2, 3. But most important, we're not only trying to highlight potential problems, we're also giving the solution. So instead of just saying, let's say, Robert, you're the supervisor of the shift, we're not only going to tell you you have a potential delay in delivery or you have a potential bottleneck in area number 5. We want also to give you the solution. And the AI, once implemented, does it very well. We contextualize the production situation. We contextualize the business rule and the business goals and the business KPIs. And then in any given situation, we are finding the best optimal solution. And the system teaches itself, continuously teaches itself how to offer better and better solutions for the ever-changing situation and environment.
How do you do that? What kind of data do you need? Do you use a reinforcement approach? Can you go a little bit more in details?
Sure. First, it's a proprietary technology in ours, and it's actually an integration of reinforced learning with optimization solutions, optimization heuristics. If you think about it, there are really an infinite number of scheduling scenarios and solutions to any given scenarios. So clearly we cannot search for all of them, but with the AI, we can actually search many of them. But there too, you want to search, let's say, in the right direction, in the right area. So this is where the AI helps us navigate the infinite number of solutions to quickly find a very, very high quality one. And should there be a disruption or a change needed or a shift in priority, we can very quickly adapt accordingly. And the beauty here is that as you run more and more data, the system gets smarter about it. And by the way, your priorities are different than mine. We can talk about that as well. But also, we don't need mountains of historical data to get started. Once we deploy our system and we onboard, let's say, your factory into our system, the system starts creating very high quality results for the different employees and stations immediately. And then it gets better. Yeah, what we've done very well is introduce the knowledge of manufacturing and manufacturing best practices to overcome the gaps in data.
How do you set up the ideal process together with the workforce, with the employees, or is it a theoretical process? How do you do that?
Well, it's an excellent question. Fundamentally, our discussion with our customers is a business discussion, right? It's not a technology discussion. And we talk with our customers about their business goals. For example, improvement of on-time delivery or reduction of waste or whatever it may be. And as we develop this discussion, we often find that they have different goals and conflicting trade-offs. Let's say I can create 2 schedules. One, which is very high on on-time delivery, but extremely costly in terms of, money. The other alternative is saving a lot of material, but perhaps we're a little bit late here and there. Now, some customers would have a very strict preference. We always must be on time, no matter the cost. And some customers will say, you know what? It's okay. I can work it out with my client. If I'm a bit late, then I can save some money. So first of all, our ability to understand the full process of the factory and our ability to model the different business KPIs to the point where we can create alternatives and weigh the trade-offs is very fundamental to answering your question. And then we can offer them the optimal choice.
from my point of view, many companies find it difficult to distinguish between reinforcement learning approaches and optimization problems. They try to solve an optimization problem with a reinforcement learning approach, and that make a big problem out of simple one. You know what I mean?
Yeah.
So how do you proceed?
Yeah. So actually, we are aiming to get the best of both worlds. And if you think about it, when you try to optimize, especially if it's an NP complete problem with an infinite number of options, you can basically search forever and you'll never know you found the best option. There's always the possibility of something better. But this is a theoretical statement, right? We're now in a business environment and we have so many seconds or so many minutes to come up with a solution. So we must be able, as a business, to attain offering a commercial software. We must be able to come up with very good, excellent solutions in a very quick manner. And here, yes, our ability to integrate the learning processes into the search has proved itself to find very, very high KPI solutions at great scale, by the way, and very quickly and fully automatically. Now, when we search, by the way, we don't run only one search heuristic. We run a multitude of them. So the real question is which search heuristic or heuristics to run where and when, in which situation, in order to find a great solution in reasonable time. And this is where the learning comes in.
Okay. I remember some figures from your customer Airbus and improvement of manufacturing floor efficiency by up to 10%. How do you do that? Can you explain a little bit the use case?
Sure. Allow me to be a bit cautious about details given their confidentiality. But in essence, this is a factory that makes aerostructures, parts for airplane. And here we see really, a number of challenges. First and foremost, the materials are carbon fiber materials. They're very expensive and very delicate. They're time sensitive. So there's fundamentally a challenge of which material to use for which job before it expires and make the optimal use of it. But of course, the choice of materials is integrated with the choices made around the production plan. So in many such use cases, we see multiple goals. One is to ensure high rates of delivery. And of course, we all know in aerospace, there's a very high pressure now to increase production rates. But at the same time, we cannot fail quality. So let's say you've made a part and you've made it on time, but the material has expired beforehand, then essentially we've made scrap. And that's a very costly mistake in both, in every possible manner. So our ability, first of all, to track and monitor materials on the one hand, but then also help the team make better choices on the use of materials, which material for which job, when, how to process it, how to cut it in a manner that reduces scrap. For example, you can take two parts and process them together. You save time, you save material, but you create some labor overhead. So, of course, there are trade-offs. So our ability to manage these trade-offs and ability to find the right balance for any customer, Airbus in this example, has been proven very powerful.
Reinforcement learning sounds for the most people like magic. Please explain us why it's not magic. Why is it hard work, difficult work to realize reinforcement learning approach?
Well, thanks for the question. I think it's a great question. Many models we see out there are very much on the basis of trial and error process. So we see a lot of black box or magic mentality. Someone with a model will say, I'm not sure what I'm looking for. Can you provide me a lot of data or all the data you can get? And I'll run it through the model and let's see what I can find. And if it worked, great. But if it doesn't work, we'll need to try something else. Obviously, it's a very difficult approach. It's not very practical, and you need to be lucky. What we found very useful are really two things. First and foremost, domain expertise, but also the ability to embed the knowledge into the model. But, when we talk about domain expertise, obviously, as a company, we know AI, we know it very well, but we also know manufacturing very well. So we're not offering AI solutions for other problems like pharmaceutical research, right? I know nothing about pharmaceutical research, but my team is not only data scientists and AI specialists, they're also manufacturing specialists. So we understand the problem very well and also understand how to solve it. The other part of it is to introduce this knowledge into the product. And here, let me give you an example. In the early days of AI, we were all amazed that you could take, millions of pictures of a cat and feed it into the Google model, and Google realized it's a cat. Now, this is an incredible AI achievement for the time. Today, obviously, it's more trivial. But if you think about it, why do we need a million pictures of a cat to know it's a cat? Any child knows it's a cat. So how do we train the model? How do we teach the model to know things that, the industry already knows? The industry knows what is a bottleneck or how to prevent it. So you want to embed that knowledge into the model, and then you don't need a million pictures of a bottleneck to know what's a bottleneck. The other side of this is our approach for a standard application. We have standard applications for production scheduling, for materials optimization, etc. As such, they solve a very concrete business problem. We're not trying to solve all the problems of the industry, only those that are addressed by our applications. That standard application has a standard model. That standard model, needs data A, B, and C, but doesn't need data X, Y, Z. So we're able to implement it very quickly. For example, for scheduling, we need to know the layout of the factory, the processes, the bill of material for any given part. We need to know, the rules of the business and some parameters around it. But for example, we don't need necessarily the temperature reading from machine number 7.
Yeah. How robust are the models?
They're very robust because, we've invested a lot to make them such, because this is production grade.
How do you make a reinforcement learning model robust?
I think it's the focus of the model on the specific problem. We're not trying to develop a generic model for all the manufacturing challenges. That's one. The integration we've built, and frankly, that's our expertise. Within the models, between the learning and the search heuristics, are very flexible, so that, let's say there is a new business priority or a new KPI, we can easily add that as well. So the model doesn't break in the face of a new requirement, a new business requirement, or in the face of a new kind of factory. The architecture allows to add those very well. And the mechanism that learns how to navigate, the different options of a schedule works the same, whether your factory is making car parts or airplane parts, whether it's big or small, or whether it works 2 shifts or 3. The other side of it is scale. We operate at enormous scale. We can run tens of thousands of production jobs automatically for any given plant.
Do we underestimate reinforcement learning in the industrial sector? What's your opinion?
Perhaps not underestimate, but I would say underutilize. I think there's more room for that. But here I can add, many applications go in the direction of what I would call a point solution. For example, we take pictures of parts and we can recognize defects. Okay, great. By the way, very much needed. But I think the call for action in the industry and to my fellow software providers is take it to the enterprise level, make business decisions. So the AI has identified a defect. Great. Okay, now what? What do you do about it? And this is where we need to see a lot more work. But again, not everything is for a learning model. We must see, prescriptive algorithms, problem-solving algorithms to address those kind of questions.
Do we need explainable AI for the users? For example, when there's a recommendation from your software, is it explained why the model chooses this way or chooses this way?
Yes, but I would position it a bit differently. What we found is that in order for an implementation to be successful, we must have the trust of the users. And in order to have the trust of the users, we found we need really 3 things. Well, first, trust, like any good relationship, is something you need to earn, right? You can't just demand it. And you earn it by having the software, the AI, making recommendations, first of all, that are, consistently as good or better than what the expert would have done on their own. Second, that they're not glaring mistakes. For example, if we have a navigation app that makes this unbelievably ridiculous recommendation, then obviously as a user, you lose trust. So we cannot afford that. And third, we must be able to work in tandem with the user. Because let's say we make a recommendation and the user says, that's fine, but I want to do something else because it's a better idea or because I know something that you AI don't know or whatever the reason may be. The software, first of all, by architecture, needs to be able to accept it and get on with it from that point on, not break. As you say, it must be robust. But at the same time, maybe we can learn something from the users. So the next time around, we're offering something much more in line with what their expectation is. So yes, we see it as a man-machine team. We feel that the team can do better than any one of them alone. And once the users realize that, we have their trust and the software implementation is successful.
If I want to work with you, how do you proceed? I call you and say, Avner, I want to have your solution. Is it a software as a service solution? What do I need to do?
Okay, great. Yes, first of all, it's a software as a service solution. So customers would pay us by the amount of production that we help them optimize. For example, how many stations, etc. So there's a scale here of payment also. Small companies pay less, big companies pay more. But more precisely, we enter a dialogue on the business of what you're trying to achieve. So I will ask you, Robert, why did you call Platane? How can I help you? And I'm not going to say a word about AI because I know Robert is very interested in AI, but Robert, the manufacturing plant, really isn't. So, okay, I need to improve my on-time delivery. I expect growth in my business and I have challenges to meet it. And that goes into discussion of, okay, how can I help you with this application or another? Which then goes into more specifics of, let's model your factory. And this is a very simple process. It takes a few hours. What are your stations? What are your typical workflows? What is your business priority? But that's already for the solution engineer to define. In some cases, we simply configure the software quickly and we can start running some scenarios for you or do some sort of a pilot for you and the users to gain the trust or see the value. And from that point on, there's a path to what we call production, use in real time of the system. And here, typically, we also go into some gradual deployment. We'll start with one production line and gradually increase the footprint of the system.
Great. Finally, let's talk about AI in Israel, Avner. Which 3 AI companies from Israel are worth taking a closer look and why, from your point of view?
Okay, well, great. So we talked a lot about, the variety of use cases for AI. And Israel has, I would say at this point, hundreds of companies dealing with that. And we're coming obviously for AI for manufacturing. So what I really like are companies that are involved with the physical world and things like, industrial manufacturing, smart cities, but also, healthcare I find very important. And, a few names that I've been kind of watching are from different fields, really. I think a great company is a company called Exodigo. They help with underground mapping, for utilities, for cities, for other uses. There are obviously, there's a lot of data, but how do you use the data to identify what you're looking for and how to handle it? And the use case and ROI are quite substantial because this replaces the need to actually dig. And I think they've done marvelous work. A second company that I'm actually also personally involved in deals with smart traffic management called Mobi. So imagine, a big city or state. There's, so much data about traffic, but can you optimize traffic? Can you reduce delays? Can you streamline it around specific events or also in day-to-day? So Mobi, I think, has a great solution, very interesting solution. Also in the way they deal with changes in real time, because obviously it's a very dynamic situation. But again, for the sake of transparency, I'm also personally in dialogue with them. And a third company I love is from healthcare, diagnostic robotics. They do, predictive work around healthcare, around health, our health. In Israel, the health organizations, they have a lot of digital data on us. It's a very digital computerized system. So what do we know about someone or about the data we're getting when he or she are 20 years old about can we expect when they're 30, 40, or 50 years old. And of course, for more immediate risks. So that's obviously not only a business ROI, but just good for us as humanity. So in all of these cases, I think it's not just a technology. I think we see marvelous examples of embedding very deep domain expertise in traffic, in geology, in healthcare, into the AI work, into the algorithms that create this tremendous value.
It was a pleasure to talk to you. We wish you all the best. Thanks a lot.
Thanks for having me. It's really a pleasure to be here, and I appreciate the great conversation. Thank you. Bye-bye.